Teaching contentious subjects like climate change. This module will help you understand how to teach contentious subjects like climate change. In this module, you will learn what makes an issue contentious. You will explore a variety of ways to teach contentious issues. You'll examine some climate change projections, and you'll complete 4 activities to reinforce the concepts from this module. By the end of this module, you should be able to identify approaches to teaching contentious issues, to discuss strategies for establishing the credibility of an information source, and to discuss strategies for integrating climate change discussions in your teaching. A contentious issue can take many forms. Typically, these issues are a controversial topic with large numbers of people with opposing views. Sometimes there may not be large numbers on each side of an issue, but the group in the minority could be very vocal and passionate about their opinion. Contentious issues are often politically charged and can be prominent in public discourse during election years. As mentioned earlier, people are often very passionate about contentious issues, which can elicit a great deal of emotions. It is important to remember that although we as scientists place absolute trust in science as the ultimate answer on an issue, many people in the general public, including some of our elected officials, do not automatically trust the answers provided by science. When teaching a topic that is potentially contentious, our first step is to recognize that all people may not think the way we think. Contentious issues continually evolve as our knowledge and understanding of the food, agriculture, and natural resource systems grow. Contemporary issues that may be contentious include climate change, evolution, genetically modified organisms, human vaccination programs, and immigration policy. There may be others prevalent in your specific discipline. You will be ahead of the game if you have an awareness of the contentious issues specific to your discipline and classes you teach. You may be asking yourself, why would I just not avoid teaching a contentious topic? First and foremost, the issue may be very important to your discipline and thus a critical piece of your class. Even if the issue is not a critical piece of your class, there are valid reasons for including it in your class. First, creating opportunities for healthy discussion in your classes will help your students develop problem-solving skills, which will serve them well in their future. Second, understanding different sides of an issue will expand your students' thinking and make them more worldly. Third, it is very likely that your students will interact with people with views different than their own throughout their lives. So teaching them how to listen and discuss in an appropriate manner will be a great life skill. Let's take a look at a few strategies to teach contentious issues. Read through this document from Flinders University in Australia. Using the attached handout, take a few notes about each strategy. Here are some specific teaching implications for each strategy. Planning for inclusive teaching. Be prepared. Think about the old saying, failing to plan is planning to fail. Let's not plan to fail. Create a safe learning environment. It takes deliberate efforts and time to build a classroom environment where all students feel safe to discuss contentious issues. Discuss the conditional nature of knowledge. Discuss how you arrive at an opinion and what evidence would you require to change your own opinion. Ensure inclusive discussions. Good discussion takes ground rules, so take some class time to establish rules. Encourage critical thinking. You will need to deliberately teach students how to think critically and to critically evaluate sources of information. If these are not already part of your classes, you should consider adding them. Use teachable moments. Seize opportunities that present themselves during your class. Give yourself permission to deviate from your plans and use the teachable moment to expand your students' thinking. Manage emotions. The better you know your students, the better you will be able to predict and understand their emotional reactions. Respect and overcome resistance. Recognize that changing people's opinions may not happen quickly. They might have spent decades thinking a particular way because of the way they were raised, and the semester they spend with you may not be quite enough time to cause opinions to change. Use active learning. Your standard lecture may not be the best way to teach a contentious issue. Attached is a document with a variety of active learning strategies you may want to try. Now, let's apply what we've learned. Let's think about this scenario. You are attempting to discuss how climate change impacts agriculture in one of your classes. A very vocal group of students who doubt climate change attempts to hijack the conversation. Based on the strategies you just learned about, what would you do? As we discussed previously, an important skill for understanding a contentious issue is evaluating the quality of evidence someone uses to form an opinion. We will briefly discuss one set of questions you can use to evaluate evidence. There are other strategies you may also use. Assessing the quality of a source is really about asking a series of questions. Who is in the group or author? Is it clear who wrote the source? Does the person or group seem to have the expertise needed to make a claim? How are they funded? Does the funding appear to be unbiased, or is there an obvious bias based on the funder? Who do they represent? Where do the authors work? Is it a university or an organization with an obvious agenda? What are they trying to achieve as an organization? What is the mission of the organization? Do they have an obvious bias? What key values, philosophy, or ethical position is explicit in the organization's publicity materials? Is the organization upfront about their biases, or do they attempt to appear unbiased, even if they have a hidden agenda? What evidence are they using to make their case? Do the authors use other credible sources to make their case? Do they cite any data? Do they indicate the limits to their evidence? Do they acknowledge other alternate positions? What is the source of their evidence? If they provide a source, is it credible? Do others use the same source to make their positions? Do they present contrary arguments? If so, do they present them in an appropriate manner? How strong do you think their argument is? Would it hold up to critical review? What do they want us to believe? Are they telling us how to believe, or giving us evidence and allowing us to decide? What are the consequences of their argument? Do they have an obvious agenda in making their case? Many of you probably have a great understanding of climate change science and current projections about climate change. The purpose of the next few slides is to give you a brief summary of current projections and to direct you to where you can get the most recent data. For this activity, let's apply our new understandings of evaluating sources. Take a look at these two internet sources. Based on our earlier discussion about evaluating the quality of a source, what assessments can you make about each site? A key distinction to make is the difference between weather and climate. Weather involves short-term, observable observations of things like temperature, precipitation, humidity, etc. People can see and feel weather. They live it. Weather is a part of daily conversations. In contrast, climate involves long-term measurements of weather patterns. It takes decades to experience enough weather to make observations about climate. Consequently, climate science is a much more complicated issue than weather, and many people do not fully understand climate science because they view weather and climate as synonyms. Since weather is within the personal experience of everyone, it can provide a great entry point to discuss climate change. Opening a discussion with something like, "What have you noticed about the weather this year?" is much less confrontational than, "What do you think about how climate change is affecting our area?" If you're working with older people, a great way to bring up climate change is to ask about what changes they've seen in the weather over the last few decades. Aside from going straight to the primary data sources in the peer-reviewed literature, the most recognized and reputable source for climate change projections is the Intergovernmental Panel on Climate Change, or IPCC. At the time of creating this module, the IPCC had 195 member countries and thousands of individual scientists who contribute. The goal of the IPCC is to synthesize climate research and make projections. Work of the IPCC is ongoing, but their major efforts are released in assessment reports. Assessment Report 5, AR5, is the most recent, released in 2013. The IPCC is the most reputable source for comprehensive climate analysis and information. Climate change projections are based on representative concentration pathways, RCPs, based on greenhouse gas emissions. Current projections are based on 4 scenarios, with RCP 2.6 being the lower projection and RCP 8.5 being the higher projections. Scientists have modeled climate change impacts for temperature, precipitation, sea ice, ocean temperature, ocean pH, and sea level for each scenario. When teaching about these issues, you can give the latest projections and then discuss how scientists arrived at these projections. You can also go backwards and compare AR5 projections with projections from the earlier assessment reports and discuss how our understanding of climate change is continuing to evolve. Much of the contentious opinions around climate change are centered around the causes and the role man has played in the current situation. Unless discussing the blame for climate change is critical for your course, it may be better to discuss the projections and then how those projections will impact your particular discipline. Based on IPCC projections, global surface temperatures will rise between 1 and 2 degrees Celsius by 2065 and as much as 3.7 degrees Celsius by 2100. Temperatures at the local level could be different than these projections. According to the IPCC, precipitation patterns will be quite variable, with some areas getting wetter and some areas getting drier. It is anticipated that increases in precipitation will be seen in high latitudes like North America and Northern Asia, equatorial Pacific areas like Polynesia, and mid-latitude wet regions like Central Asia. Climatologists expect decreases in precipitation in mid-latitude dry regions like the Mediterranean. It is also anticipated that extreme precipitation events will be more frequent and intense at mid-latitude regions. It is also predicted that there will be an increase in the global land area impacted by monsoon precipitation patterns, and that those monsoon seasons will be longer, with onset occurring at typical times, but ending later than historically observed. Climatologists are more confident in projections for sea ice levels in the Arctic than they are for projections in the Antarctic. The IPCC expects that Arctic sea ice packs will continue to thin and shrink. Annually, Arctic sea ice levels in September are expected to decrease between 43% and 93%. Some projections have the Arctic ice-free in September by the year 2100. The world's oceans have absorbed as much as 90% of the stored energy in the climate system. It is estimated that over 60% of the increase of energy in the climate system between 1971 and 2010 is stored in the upper 700 meters of the world's oceans. Consequently, the greatest ocean warming has occurred near the surface. Climatologists expect the oceans to continue to warm, with that warming most pronounced in the tropical regions and the subtropical regions of the northern hemisphere. Estimates range from 0.6 degrees Celsius to 2.0 degrees Celsius. Ocean temperatures also have implications for sea level rise, as water volume increases with temperature through thermal expansion, which accounts for between 30 and 50% of sea level rise. Ocean temperatures also impact ocean evaporation and salinity. Climate change is also impacting the pH of the oceans. As a normal part of the carbon cycle, increases in atmospheric carbon dioxide lead to carbon uptake by the oceans. This causes acidification of the oceans. Estimates range for a decrease in ocean pH from 0.06 to 0.07 for RCP 2.6 to 0.30 to 0.32 for RCP 8.5. Changes in surface pH of the oceans have tremendous impact for fisheries and marine ecosystems. The IPCC concluded that sea levels over the last 150 years have risen more than in the previous 2 millennia. Between 1901 and 2010, sea levels rose 0.19 meters. This equates to 1.77 millimeters per year. Climatologists estimate that nearly all the observed sea level rise since 1970 is attributable to glacier loss, Arctic sea ice reductions, Antarctic sea ice reductions, losses in the Greenland ice sheet, and thermal expansion. By the year 2100, sea levels are expected to rise somewhere between 0.40 meters and 0.63 meters. For our final activity, let's explore climate change impacts on a local scale. Click on this link from the World Bank and explore the impacts on Belize. Notice their data on Belize is somewhat limited, so also look at Belize's neighbors, Guatemala and Honduras.